Well, hello, everybody. This is Bill Bittner. Today is July 13th, 2020. We're going to have a little different presentation today. This is a presentation that a number of years ago we had talked about. I think it may have been the Share event, where a lot of the things that we do at conferences, we would always focus on the brand new technology. And we didn't take a lot of time to go back and just talk about the product in general and what were its strengths and so forth. So we came up with this idea of doing ZVM, the leader in virtualization. Now, some people would say that's a pretty bold statement, Bill, right, to say that we're the leader. In other versions of this, it would sometimes say it's the greatest. And I'm clearly biased, right? But we'll talk about some aspects of this. Now, when I first started down this path of looking at this, one of the things I had to do was think about, well, what does it actually mean to be the greatest? Right. And this is where I tried to leverage some of my friends and some of my coworkers. So I went to them in a couple different areas and asked them to name and defend the greatest. Right. So the first category was American football, right? US football, the NFL, and who was the greatest quarterback, or who is the greatest quarterback, right? And I got a number of different answers. Some people were very passionate about their answer. But then I also asked them about, well, why? Why is their name there? Or just as importantly, why are some other names not there, right? And so I would get answers like the most wins or championships, most Super Bowls, quarterbacks that make things happen, right? Joe Montana might be a good example of that here, where there were games where there's no reason he should have won, but yet they did win. He just seemed to make things happen there. Protecting the ball and being consistent. Right. This is one where it actually kept some people off the list because they didn't protect the ball. There wasn't any security level there. There wasn't any resiliency, if you want to use a technical word, right? Critical to team success. Cases where they would not have won if it wasn't for that individual being part of the team. Another one was the body of work, right? So there were some players that were outstanding, but yet they didn't have a body of work that spanned years or a decade. And so people didn't feel that they could be kept on that list. And then leveraging the teammates, right? So this player that knows the strengths of everyone around them and uses them as well. Now, I also did what's the greatest singer, band, or musical act? And I thought this would be pretty simple, but yet people were just as passionate over in this category. Right, so a lot of the names that you would expect, the Beatles, Elvis Presley, Michael Jackson, Queen, lots of different names and things that came out here. Again, the longest performing, like the Rolling Stones, they've been there since the Flintstones, basically. And so that, again, that idea of endurance and lasting through the business. Typically, most songs, albums, gold, whatever. Was another factor in there. Impact to the industry. So one of the names here that might be different for some folks is Jenny Lind. I don't know if anybody knows who Jenny Lind was. I did not. I had to learn about Jenny. So Jenny was born in 1820 and was an opera singer and came to the United States and connected with P.T. Barnum of Barnum and Bailey. And it was with P.T. Barnum that she started doing these concerts across the United States. And really that was the start of concerts as we know it today, right? And so that was a real impact to the industry as opposed to a singer or performer being based in a town for a long period of time, as opposed to just being there for a couple of days before moving on. So an impact to the industry. One person who submitted Elvis Presley. And when I asked them why, they said, well, the number of impersonators. In fact, it's kind of interesting. I guess there was about 170 impersonators of Elvis Presley when he passed away in the 70s. And the number is unclear now, but it's measured in hundreds of thousands worldwide. Right. And there was one projection that sometime here in the future, 20% of the world would be an Elvis Presley impersonator based on the growth rate. Right. But you think about that, too, in terms of this idea of impersonating. Right. And it first caught my eye a few years ago when I heard one of our competitors put out a new machine, and part of their marketing was that it had mainframe-like qualities of service. I'm like, well, it's nice that it's mainframe-like, but we are a mainframe, right? But the fact that people are comparing themselves to us was a pretty important thing. And most famous, meaningful, definitely acts that were meaningful to people, and cross-generational, right? One person that commented that Frank Sinatra, because both he was listening to him and his were starting to listen to Frank, right? So some aspects of that. I know it's been fun because I've seen a couple of scenarios here where generationals are there from the mainframe as well, where I see different generations there. Okay. I also asked this for my international crowd about footballers, right? Or soccer, as we would call it here in the US. And again, these are not my answers. These are other people's answers. So if you don't see yours there, don't get angry at me. But this was also kind of fun. People here were very passionate about their choices as well. And there were similar things in terms of the reasons, the body of work or how often they've been successful, the fact that they make things happen or are part of that. Again, consistency. So security is not just important in IT, it's important elsewhere as well. Competition, who they played against, kind of this idea of that you're in a business that's important and competitive and doing well. The fact that they've influenced the game, right? There were some people that talked about that with Pele, that just his influence alone was significant. Those that made a team better overall, not just their stardom, but making the team better overall. Okay, so I thought that was just a fun little segue there. But as we think about those sorts of things, you'll see and realize that a lot of that's true from a ZVM perspective as well. Now, I want to talk a little bit about the ZVM design philosophy, and even some of those in the lab might say, "What are you talking about, Bill? What design philosophy?" Because I can't point you to a book or a document other than this presentation that really talks about the design philosophy, right? But it's one of those things, again, that gets passed down, right? So this is actually Mark Lawrence, one of our developers. He works in scheduling and dispatching, working with his grandson to learn the piano, right? So these things that we pass on that are important, I believe. So the first one is this idea of the replication of the architecture, right? And this seems simple, but is a pretty significant thing, right? So this idea that ZVM creates virtual machines with a high degree of architecture fidelity, that it is the principle of operations which defines the architecture for Z. We obey those rules, right? And in obeying those rules and confirming to those, that gives people writing software on top of us a great deal of trust and confidence of how well it will work. In fact, let me just pause and talk a little bit about if you've never really looked at the principle of operations and our architecture in general, I encourage you to do a little bit of that, right? We have a very well-written architecture, pretty significant there in terms of the amount of effort that's put into documenting that before we're starting to do anything in silicon, right? Now, whenever we do a new processor family, there's a set of programs and tests that get run on top of that processor family to validate that it's adhering to the principle of operations. Now, we also take those same test programs and sort of pick them up and put them down inside a virtual machine, and they need to get the same results, right? They have to obey those rules, right? Or ZVM has to obey that. And so this gives us a lot of value in this. Part of this is that vendors, they'll trust that, right? So this is one of the reasons why some ISVs will certify solutions in a ZVM environment where they may not certify it in other virtualization solutions. And also one of the things that not everyone knows is that some of the new hardware features actually get implemented in software in an internal version of ZVM that before it actually goes into the hardware. So that does give us an advantage in refining that architecture and adhering to it. Okay. Another kind of design principle here is the fact that we're part of a bigger IBM picture. So that's important in a couple of different ways. One is that we don't try to do everything and be everything. And I'll come back to this in different ways later on. So we view ourselves as part of an entire IBM stack. And with that, we also inherit the benefits of the platform, right? The stability of the hardware, the security of the hardware, all those things are important. But it also gives us an advantage in terms of how we can work amongst the stacks. right? And I have a couple different examples here that I think illustrate the advantage of having that stack all owned by one corporation. Besides those, there's also the testing advantages in being able to do that. Let me just pick one example here. So QEBSM, right? So the QDIO Enhanced Buffer State Management Assists, that's what allows us to do IO in a guest environment with FCP SCSI with very low overhead, right? But to implement that, there were changes both in the Linux kernel, or not just both, but in multiple places, the Linux kernel, in ZVM, and in the firmware, right? Now, that could have been done if there were 3 different corporations designing that stuff, but it was a lot easier when it was all one company doing that, right? And so that's something that we don't want to lose sight of. Also, you'll think or realize that some of the enhancements that we've put into ZVM are in conjunction with those other layers, right? When we worked with the Java and WebSphere folks and recognized that garbage collection was a pain point for some of our customers, right? And working through that, the result of that was guarded storage from an architectural perspective, or what we call pause-less garbage collection. And that meant changes in multiple layers of the system, but address those things. The third kind of principle or guideline here from a philosophy perspective is the fact that we have a ZVM community and that they're critical to our success. Now, way back in 1976 is when VM, from a VM share perspective, the share community put together an electronic conference, right? So forums or discussion groups were created back then for this. So it's amazing how much additional assistance and help and cooperation we get from our customers and the ISVs. In one sense, I kind of joke that we were sort of open before there was open. Now, we're not licensed that way, right? But there still is that degree of communication and cooperation. Also, and again, I'm probably biased here, but I tend to find that the ZVM community is friendlier. There's less flames and so forth. It's very, very rare on the IBM mailing list, IBM's VM mailing list, to see somebody jump on someone about a stupid question, right? In fact, if somebody does, they probably get twice as many people jumping on them about being nice. So with that, we have this long history of different tools being added, even modifications to ZVM at different times. In addition to that, the ZVM customers and vendors have a long history of influencing and steering IBM, right? Guiding us through that. I think we got away from that for a period of time, but I clearly believe we've gone back to that, right? So with things with the ZVM Council and other venues where customers can influence and give us feedback has been really valuable. Another thing is this idea that we had to recognize the need to be adaptable. And so it's pretty amazing when I stop and think about the diversity of the customer environments that we run in. So what I'd done when I put this presentation together is I went out and I looked at some of the breadth of environments that we have out there, right? And so it's a span of 100-fold for memory at the time. It was 32 processors fold. It's probably bigger now in that case, probably 800 times in terms of the virtual machine sizes themselves. And IO devices, a big span there as well. And part of our goal is that we continue to run well in all those environments, right? That we don't just focus on our very large customers with 2 terabytes and 80 logical processors. It was kind of funny. I look back in 1992, I had a client that was using Office Vision, some of you that remember that, and they had over 20,000 virtual machines, right? Back in 2010, we would recognize that there were customers with more than 500 virtual machines, Linux virtual machines in that, right? And essentially, the core of the operating system, the ZVM system, was the same, right? But the fact that we can handle those things is pretty significant. Okay, protecting the customer, both in terms of their investment and a security perspective, right? And that comes in different flavors. The compatibility of programs, right? I often would joke with people about, look on your A disk and tell me the oldest program there, right? And so I know I have some from the 80s, probably some out there that are even older than that for other people. Security, this idea that you can't just say you're secure, you have to prove it. To have some body of work that says you're secure, capability like that. Now, also beyond that, we spend a lot of time with different certification bodies to certify the ZVM product. Whether that be from a FIPS perspective or common criteria or others, right? There's different country requirements. So different countries in the world will have their own certifications that we'll occasionally go through. And in addition to that, we have an integrity statement, right? So that's out on the website. ZOS has one as well. So it's this idea of a statement that validates our integrity from a data perspective and from a construct perspective, right? So that's going to give you some background on why there's essentially a virtual air gap between virtual machines, just like there would be an air gap between physical machines. And on top of that, if you're not reliable, if you're not stable and maintainable, then you're not really secure, right? And the idea that we do focus on problem determination, we don't just say reboot and see if it happens again, and that recognition of the different business needs. Also, we've always been focused on trying to empower the customer, right? And so there's a lot of capability that we've provided to clients from that perspective, whether being able to modify the control program with exits to all sorts of different utilities and capability that's there. I know Neil Ferguson from Sine Nomine used to describe ZVM as a intelligent and programmable BIOS. And so I think that captures it well. Okay, so let's start talking a little bit about customer value and some aspects that a lot of this will be common sense to many of you. So I'll walk through it rather quickly, right? So we start out with this concept of I might have an application, it might be out there, and it might be made up of multiple servers from a discrete server perspective. So I may have a HTTP server there, I may have a JVM or application environment, and then maybe there's a database involved, right? Now, I'm going to want to have two of those for redundancy because maybe I'm on hardware that's not as reliable as the mainframe. And then I'm going to also add some more from the scaling perspective, right? That those individual servers, can't handle the load. And then I'm going to have some for testing. Well, I start adding these together and I get a lot, right? This concept of server sprawl that's been out there for, a good decade now. And it's funny, we'll sometimes engage with clients and it sometimes takes them a while to figure out how many servers they actually have, right? They might be owned by groups, or they just don't track them all in one place. All right, so what we're going to do is we're going to pick that up and essentially drop that in to a ZVM system. Now, often there'll be a TCO study or so, total cost of ownership or operation, right? And so this is the idea of what does it cost you to run and operate a system over time? And we do really well in this kind of comparison with our competition. Other things that can be studied is total cost of acquisition or TCA, right? Is what does it cost to buy all the parts? Now, in ways, some of our hardware and solutions are more expensive, but you have to remember the quality that's there and how that's going to factor into actually running a system. So when we do these studies that look at the cost of actually running a system, and especially when we do it for 3 years or more, we come out really well. And especially when we're not looking at just a trivial number of servers, right? There's tends to be a point at which we really shine from a consolidation perspective. And also when you factor in all the operating expenses, right? So I can recall one client that said, well, we're not going to factor in the building of the data center because the building's already there. And so, well, what about the power? Well, we have to buy power regardless. Well, the amount of power you buy might be a little bit different, right? So those folks that want to limit what they're factoring into the expenses, they won't see as good a story, but that's important. And software licensing, that's a big part of this. If I can consolidate a 10-to-1 kind of ratio from a core perspective, that's 1/10 of the licensing cost, perhaps, right? So things of that are really important. If you go up into like a 5-year TCO, that's really good, especially because in those scenarios, you're often factoring in what's the cost of me refreshing all the hardware, right? Where we can do that really well, really efficiently. Okay, so I have the system here, it's cool, but the system programmer might want some things to allow them to manage the system and be more reliable in doing that, right? So we can start bringing in things like RACF, right? So an external security manager there. Dermate, something to manage the directory so I'm not doing that by hand. Operations manager, as well as backup and restore manager, right? So these things that allow us to be enterprise ready for the solution. And then I might have questions about, well, how well is the system running, right? And so I can bring in some things like performance toolkits or Megamon XE for ZVM, right? That allow us to not only look at how the system is running, collect data, do capacity planning, but a lot of these different things and problem determination. Now, I used to joke about when I'd ask people on average how busy were distributed servers, and you'd get numbers, 15%, 20%, maybe 30% on average. And I used to joke that those are always nice round numbers, so I'm pretty sure somebody's just making it up, as opposed to telling me, 37% busy. And in some cases, that's because it's difficult to measure and pull together all those numbers in a simple way. But when I use tools like Performance Toolkit and a Megamon, it's pretty easy for me to be able to say, all right, this is how busy my LPAR is, or my server in general. So those are really valuable things to have there. So let me get to this point now, like, okay, so I have that, I brought in what was out there and consolidated it, but how can I grow, or how can I let others use the system better? And this story has changed at different times over the years, but some of the solutions that are there is IBM Wave for ZVM and Linux. And so that's one management solution there that can make it easier to set up and manage virtual machines. It is a ZVM specific solution, right? Now, things that have a little bit more breadth in terms of management capability and at a higher level are things like the IBM Cloud Infrastructure Center, as well as OpenShift Cloud provisioning with Red Hat. So again, more solutions there that allow us to grow this environment and allow people to do that with less ZVM specific skills. And then, of course, there's different OpenStack solutions that people can bring into the mix as well. Some of the things I talked about already connect or do leverage OpenStack. All right, so I have all this, but I may start to get to the point where, can I have more virtual than I do real? Can I do that? And we all know the answer is yes. But sometimes I get questions about, well, yeah, but how do you do that and how does it work? So I'm going to look at that both from a processor perspective and a memory perspective here. And we'll start with the processor. Now, there's a few things, again, because we're part of a larger stack, we can do some things. And so we're going to leverage some of the hardware there. So things like hyperdispatch and topology awareness, right? The fact that ZVM being spanned across 40 cores, or maybe even 80 cores, depending on how we have things configured with SMT, I'm now dealing with multiple layers of cache, right? Up to a level 4 and then actual memory itself. And so being aware of where things are located in that electronic complex is pretty important to getting the most efficient performance out of things, and also balancing efficiency and latency. The SI instructions, so start interpretive execution, right? The way that we dispatch virtual CPUs in a ZVM environment, and actually Prism will turn around and use that as well to dispatch logical processors. The enhancements and different things that have occurred with the SI instruction over the years is again part of that partnership between the hypervisor team and the firmware and hardware teams, right? SMT support, right? I'll talk a little bit more about this in a couple charts here about some of the things that we did differently there. And again, this is another one where we can bring in better capacity to the system through leveraging that. And then various hardware assists, right? I already mentioned the QEBSM, right, as being one of those. Different technologies like that allow us to run more efficiently in this environment. So on top of this leveraging of the hardware, we also have some things that we do from a ZVM scheduling and dispatching that I thought were worth calling out. One is that we're designed for mixed workloads. We recognize that different virtual machines will have different dispatching patterns or approaches, right? And so we try to work with that from that perspective. And what's really busy at one moment may not be busy the next, and how do we transition between which virtual machines are busy. This concept of being able to have a guest yield its time or yield control to the hypervisor when it's sitting there spinning, right? Because in a shared environment, if I'm a virtual CPU running Linux code just spinning on a lock, that's just a waste of everybody's time, right? So we have technology that allows Linux to say, hey, I'm just sitting here spinning on a lock. ZVM, why don't you go dispatch something else to make it more efficient? something we call test idle, which I won't go into a lot here, but it's just another feature that we have that recognizes virtual machines that may be either guest machines or server virtual machines, right? And allows us to handle the dispatching with that a little bit more efficiently. And then last is this idea I'd always taken for granted. I thought all hypervisors did it. And that's the idea that if I have a virtual three-way, when ZVM dispatches that virtual machine, it doesn't have to dispatch all three at once, right? Especially if that virtual machine only has work to drop one. Essentially have a level or a degree of independence in dispatching of the virtual CPUs. Now, we still recognize that in a virtual way, the virtual CPUs are part of the same virtual machine. So we're going to consider that when we do our dispatching from a topology perspective, right, and an SMT perspective. Okay, and then there's just some questions about, well, what does that result in? And so virtual machines, some of you may recall back in the early 2000s, Sine Nomine, one of our business partners out there, ran some tests, and one of them was called Test Plan Charlie. I can't remember the exact number. I think it was 92,800, something like that, virtual machines. Now, that was back, as I said, in the early 2000s. So that was an older style machine as well, processor, right? So we're pretty comfortable that we can run as many virtual machines as you need in terms of the actual constructs involved there. Each of those virtual machines could have up to 64 virtual processors. We have low context switching. So the cost from a ZVM and firmware perspective in switching in between virtual CPUs, while there's still an expense there, it's fairly low compared to some other solutions that are out there. And scaling up to 80 logical processors on the newest machines. So good things there. So I want to talk a little bit about SMT, just a few charts there to illustrate some things. So first off is this idea that in SMT, from a terminology perspective, what you purchase are IFL cores, physical IFL cores, right? You configure on your HMC logical IFL cores. Now, on some of the screens, they're going to call them processors, but I want you to think of them as cores, because each core with SMT allows us to have two threads, or what ZVM is going to look at as CPU or processors, right? And then on top of that, a Linux guest with virtual CPUs will dispatch on those threads, or from ZVM's perspective, the logical processors there. And again, we'll be topologically aware when we do that dispatching. So another aspect of SMT is this concept that if I'm running without SMT, an instruction stream is going to have the full benefit of that core, right? And so just for illustration purposes, let's say it gets 10 instructions done in a period of time. Now, if I enable SMT, I now have two threads. Those threads themselves, those instruction streams, may execute slightly slower. In this case, I'm going to just use 7 as an example here, but I have two threads. So an individual instruction stream is going to slow down, but overall, I get a 40% improvement in my capacity. And again, these numbers are just for illustration. Now, part of what that means is, how do you report processor time now, right? So there is something called raw time, which is just how many seconds of CPU time, how many seconds was the virtual CPU dispatched and running on a thread. Now, that means kind of different things if SMT enabled or disabled, because in one sense, this is out of 10 possible units versus 7 possible units, right, based on the speed of those instruction streams. So one of the things that we introduced when we did SMT was something we called MT1 equivalent time, so single thread equivalent time, right? So if you're running in an SMT environment, we're going to project or estimate how much CPU time would it have taken if you were in a non-SMT environment. Right? And typically we would use this for things like chargeback. And then finally, since most software that runs in this environment is licensed on a per core basis, we want to figure out how much core time was used. So we have a metric called prorated core time, which in a sense kind of discounts that raw time for the overall core and distributes it across those virtual CPUs. Right. And so that allows it to be suitable for things like license metrics and things like CPU pooling or resource pools. Now, I mentioned that not really to talk about SMT, but the fact that that's some fairly complex stuff, and we do that, right? We felt that that was important to do, whereas some other solutions don't. They just still give you just raw time and only raw time, right? But we like to be able to measure things. We like to be able to get to a capture ratio of as close to 100% as possible. So let's switch gears and go to the memory overcommitment. So same sort of thing from a ZVM host efficiencies perspective. There's things like the pageable page tables. So if you're familiar with the dynamic address translation set up in IBM Z and Linux 1, you have region tables that point to segment tables that point to page tables. And those page tables in ZVM for virtual machines are actually pageable. So we can actually page them out. So this is one of the reasons why the expense of having virtual machines instantiated or started in the VM environment don't penalize us as much as it might perhaps on some other systems. Block paging and page throttling. So this idea of being able to move multiple pages out to disk with a single IO and doing some throttling there where we don't overrun our disk devices. Algorithms based on fairness. Just this idea of who really should have to page the most. That seems like a simple thing to state, but when you start looking at it from a implementation perspective, it becomes a lot more difficult. Because first you have to define what is fair. I sometimes joke that this is sort of like saying that the tax system should be fair is easy, but defining what fair means to everybody is a little bit more challenging. And then again, things like hardware assists. So the host page management assist, HPMA, is an example of that. Right. And then there's some things where there's some host and guest collaboration. So we have this concept of asynchronous page faults. So if Linux is running and we take a page fault at the ZVM level, we can allow Linux to keep running, allow it to dispatch a different process while we handle that page fault asynchronously. Shared segments, many of us know that these have been around for a long time, different capability with those. CMM, cooperative memory management, this idea of being able to signal Linux guests and telling it to stop using a certain amount of memory or to start reusing a certain amount of memory. And then this idea of swapping to a virtual disk, which we've talked about in the past, which allows us to minimize the size of the Linux virtual machines, but so when they do swap, they're swapping to a virtual disk and storage, which is going to give us performance that's close to memory speed, right? But when that data is not being used, that can be paged down. So it kind of gives us the best of both worlds. From a how many perspective, up to 2 terabytes of virtual machines, 4 terabytes of real memory, 64 total instantiated virtual memory, and then good scaling up to the 4 terabyte limit. Now, I get a lot of questions about, well, how much can I overcommit memory? And you should all know by now the answer is it depends. So some of it depends on the guest provisioning. If I really oversize a guest for some reason, then it makes it easier in some cases to squeeze it down. What percentage of the workload is really active at any one time, right? So in some test environments, testers will bring up virtual machines, but they won't be using them, right? So in those cases, it's easier. Is the workload sensitive to latency, right? Some continuous workloads that are very bursty, they don't do so well with having to be delayed by paging. Other things are a little bit more tolerant of those things. Different software mix, depending on what's running there in the virtual machines. The service level agreement, do all transactions have to be sub-second or just 99.9%, right? And then finally, just the capacity and bandwidth of your paging and IO configuration. This is the thing that I think has become more important in the past 5 to 10 years as we've been transitioning from spinning disk to solid state or flash memory disk, right? Where that's allowed us to overcommit memory a little bit more because of that better turnaround time when we do paging. Okay, so we have this overcommitment of resources and so forth. One of the other things that comes up is, well, that's good, Bill, but I don't want to put everything in one place. I may have policy requirements where I have to separate production and test, or I just don't feel comfortable having everything in the world run on one system, right? Well, that's where we can often leverage the fact that we have multiple layers of virtualization in IBM Z and Linux 1. So the Prism or LPAR management, we can now create multiple LPARs, have our different ZVM systems running there and separate things from that perspective. With that also too, we have a lot of flexibility in terms of adding sources dynamically, both at the virtual level and then also at the physical level, right? So the fact that I can add processors and add I/O and add memory dynamically to ZVM. I can remove most of that dynamically as well. And then again, the fact that we virtualize the architecture. So since the architecture allows for and defines this dynamic capability, right? So dynamic storage reconfiguration, that part of the architecture, we implement that from a virtual perspective. So Linux guests and ZOS guests can handle that as well. I won't spend a lot of time here, but just point out that there's also something known as the ZVM mode LPAR. Some people call it a mixed mode LPAR, right? And so that's the idea that in this LPAR here, we have a combination of general purpose processors, ZIPs, ICF, and IFLs. And we can handle dispatching and running those different types of guests with those different type of processors there. So this gives us even greater flexibility for some environments. The global vSwitch, the fact that I'm going to have multiple Linux guests across multiple LPARs, 3 LPARs in this case, each with a virtual NIC on there. I'm going to have a set of OSA cards, OSA Express adapters here, and I'm going to end up creating a global vSwitch that can span those LPARs and allow me to do link aggregation, not just across a vSwitch in an LPAR, but across those LPARs with those 3 OSAs there. And so this gives us a great deal of resiliency, right? Pretty much if any one thing goes down, we're okay here, other than if the entire KEK goes down. And so we have some great capability with that. And on top of that, there's some automatic load balancing. So some things like that are pretty significant to this. Okay. Now, we'll often get into this question about not all work is equal, or not all work is, from a priority perspective, equal. Right. And so we can do some things from a prioritization perspective. In some cases where we have clients that have a massive database, we might run that Linux virtual machine and database in an LPAR by itself. In other cases, you'll see illustrated here that virtual machines can be different sizes. They can also be a different number of processors. I can give higher processor or memory priorities in that with different settings. I can create a pool, a CPU pool, or a resource pools, and put a set of guests in there and limit them as a group. I can do all these different things to do that. I can also leverage things up in Linux, such as CPU plug D, which does both processor and memory management from a Linux virtual machine perspective, right? So that Linux guest can dynamically change how it's built based on the workload that it's running and the rules that you give it. So some capability there. Steve Cook, not too long ago, talked to us about GDPS. His charts were more sophisticated. Mine are pretty simple in that, if a big rock falls on a server, we want to be able to fail over. Likewise, sometimes that rock might fall on the person as well. So those are rocks. Somebody suggested that's a potato, but trust me, it's a rock. So when that happens, we want to be able to automatically hyperswap over and switch over to the other server without disrupting the applications and the environment there, right? So things of that nature that are important. SSI, we spent, I think, 4 different weeks talking about that. So I'm just going to kind of flip through these charts. So we have relocation domains. And remember, that's another thing that's fairly unique to the ZVM implementation. There's others that do a little bit where you have to hard code exactly what machine you want it to be mimicked to, as opposed to the system discovering and setting up and managing that on itself. We've talked about some of the different solutions and things that you can implement. We have that capability there for planned outages, right, to move work around when we're doing that. Different testing isolation, the administration savings of being able to apply service once, put in production elsewhere. The idea of having one directory for the complex or the cluster. And to some degree, that increased isolation capability of managing things there. All right, so I'm going to skip over the examples I have in here. You might recall these from the session we did before, right? Production with protection, right? That was that idea of a new application I roll out, I'm going to put down in a set of members of a cluster apart from general population. Think of it that way, right? Once those new applications look like they're running well, then I can move them up into the true production environments, right? And I can do that without having to rebuild everything. I can either just use live guest relocation or shut them down and bring them up over there. We also talked about this example in the past where I have a 2 KEK environment, two IBM Z or 2 Linux One boxes. I want to bring in a new one, so I'm going to move work off of the one KEK, the one server, shut those members down. I'm going to bring in the new box and then move that work back, right, using live guest relocation. And I end up having upgraded the hardware without having stopped the virtual machines at all. So pretty cool technology. We could also do that again with a machine up top there, right? So again, we have that all up and running. And in the weekend, updating the hardware on servers. So think about that when you think back to things like the total cost of ownership. Let's say I had 100 discrete servers out there. What would it cost to upgrade that hardware once every 3 to 5 years? Even if I do 2 boxes a weekend, that's a full year to do that 100 discrete servers. Okay, so I sometimes get questions about, well, ZVM is difficult to use or hard to learn, right? I sometimes explain it this way. If you looked at the manual for using a handsaw versus a multi-beveled miter saw, one instruction manual is going to be a little bit bigger than the others, right? Now, that's not to say that we're not trying to make ZVM easier to use. We definitely know that we have room for that. But I think it's important to keep this in mind, in that part of the complexity of ZVM is it has so much flexibility and capability. Now, I think that's part of the challenge in another way, in terms of, if you look at the documentation for ZVM, it can be overwhelming because there's so much there, right? And so what we started to do and are trying to do a better job of is making that more concise and allowing you to read less to get started before you later on you can read more to get the full value of it, right? But I just want to keep that in context. The other thing that I'll bring up is that, when talking to many clients, while there is a learning curve there, you can learn it, and we shouldn't forget that. Okay. So just kind of wrapping up here. One, this is just a list of things that often come up in terms of pain points or what I want to do from an IT perspective. So maybe I'm the CTO or director of IT for a company, different things that come in there that aren't always on the spreadsheets, right, but are still important to the environment. And so I think most of these things we've addressed throughout this presentation. And then also kind of a last summary chart here, or what I call the placemat. So this was actually a chart that myself and somebody else was asked to put together, because there was an executive who wasn't quite sure why we had multiple layers of virtualization, right? And so part of what I wanted to convey to them is that from an LPAR and PRISM perspective, it's really about the focus on isolation, right? Whereas with ZVM, it's more about flexibility, right? And so all the different things I think that factor in and allow us to do different things are important. And so that's sort of where this chart came from. So again, this was kind of a little bit lighter presentation for you all, but I thought it was good every now and then for us to go back and look at the product as a whole. Okay. All right. Have a good week. Talk to you next week.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.